Here's a cosine function, and also notice that we're making things a little bit more complicated now because we have an equation of the form y equals 5 cosine 4 pi x. So we have a coefficient in front of the cosine, and we also have a more complicated expression inside the cosine function. So to kind of sum up where we're at right now, I have these steps. This isn't our final process because we still have more issues to consider, but right now we're kind of at this position. We can graph functions of the form y equals a sine bx or y equals a cosine bx. The absolute value of a is what we call the amplitude, and we got to pay attention to whether a is positive or negative because that tells us how to start the shape of the graph. The period is going to be 2 pi over b if b is positive, and b will always be positive for us, by the way. Now you can use this formula, or you could set up an inequality if you prefer that way of finding the period. Number 3, divide the x intervals from 0 to 2 pi over b into 4 equal parts. We've done that once, and we'll see how to do that in the next couple examples again. We're going to plot the 5 important points from step 3. They correspond to the quadrantal angle values for our basic sine and cosine functions. So they help us find the zeros and the high points and the low points on the graph so we can draw our wave. And then I want you to add at least one more period to your graph. I'd like you to draw at least 2 full periods for every graph that we sketch. So let's go ahead and apply these steps to this function y equals 5 cosine 4 pi x. So we can see here a is equal to 5, so the amplitude is 5. And we can set up our y-axis scale now however we want. So I'm not going to label everyone. I'm just going to say this is 5, and here I'm going to label negative 5. And now let's see, b is equal to, now b is the coefficient of x. The coefficient of x in this function is 4 pi, 4 times pi. The pi is part of b. So the period, using that formula 2 pi over b, is 2 pi over 4 pi. The pi's are going to cancel, and this fraction reduces to 1/2. So the period here is just 1/2. You could say 1/2 radian, right? And what we want to do is take the period and divide by 4, which is 1/2 divided by 4. Half times a fourth is 1/8. So I'm going to use eighths to mark off those important values, right? 0, 1/8, 2/8, 3/8, and finally 4/8, which is a half, and that's 1 period, right? So those are the important points I'm going to label. Of course, 2/8 is a fourth. So up here on my graph grid, I'm just going to label 1/8, 2/8, which is a fourth, 3/8, 4/8, which is a half, and there's one period. And notice I'm not putting any pi's on the horizontal axis at all. It doesn't mean they're not there, it just means I'm more concerned at labeling these exact fractional values, radians, because that's going to make it easier for me to plot the important points on the graph. Now, I'm graphing a cosine function, so I know I'm going to start at a high point, then a 0, then a low point, then a 0, then a high point. Instead of my high point being at 1, because of the amplitude here, I'm going to start at 5, then at 0. So that first portion of the graph dips down to 0 at 1/8. At 1/4, I'm going to be at -1. At 3/8, I'm back up to 0. At 1/2, I'm back up to 5 units. So, I mean, it looks a lot like a typical cosine wave, but it's different because of the way in which I've labeled the horizontal and vertical axes. And we're actually almost done with our graph. We just want to add one more period. I could either go to the right or to the left, doesn't matter. I'll go to the right since I have room. 1/8, 2/8, 3/8, 4/8. This is going to be 5/8. 6/8 is 3/4. 7/8. And then 8/8 is just one whole. And this pattern's going to continue where I go down. At 3/4, I'm at -1. 7/8 is 0. Excuse me. At 1, I'm back 1 unit up above. I could have extended the graph in the negative direction. And some people like to do that because you can just use the opposite of the x values you already plotted, and the symmetry of the cosine graph would give me something like so. So I actually have more than 2 full periods sketched here. And I think that's all that we want. But there's one more thing I want to show you about this graph. I want to superimpose the regular cosine graph, and it's kind of a pain. I mean, somewhere is pi over 2. Pi over 2 is about 3/2. So pi over 2 is actually about 1.5. It's like way off this grid, right? Because I only went out, this is like one radian, okay? So what I did was I went to Desmos. Desmos never complains. We'll just draw what we want. And I graphed, I hope this will show up here. Let's see. All right, I'm not getting it. Shoot. Oh, there we go. I just want you to see that I graphed 5 cosine 4 pi x and cosine x together in Desmos, and it set up a scale. I altered it just a little bit, and it's drawing many periods of the 5 cosine 4 pi x graph. The blue wave is the regular cosine, so it's giving quite a bit more of the horizontal axis than I did in my drawing. So I'm getting many periods, but notice the amplitude difference. And so the 5 cosine 4 pi x has a much greater amplitude. It has a much smaller period than the regular cosine graph. I just want you to see this picture of how those two could be drawn together. And that's what the formulas would look like in Desmos. And there's my graphs. So sort of cool just to see how easily Desmos generates that picture. And that's that.